Okay guys, I'm going to do the video for day 2. I'm not quite sure why it didn't come out because I recorded it once, but we're going to do it again. Okay, so we are in your packet on page 28, and we are going to find the equation of the curve through 1, 3, given that slope. Now, one of the biggest mistakes that I get every year when there's a test question like this, some students will think it's saying find the equation of the tangent line. It is not. It is saying find the equation of the curve. So we want to be careful. We know slope means dy dx. So the very first thing that we're going to do is just change slope to dy dx. So dy dx equals y over x squared. Then we're going to separate the variables. So I'm going to multiply both sides by dx. Then I notice this y needs to go over with the dy, so now I'm going to divide both sides by y, and then we can integrate. Now when we integrate, we'll get ln absolute value of y equals negative x to the negative 1 plus c. I called it c1. Now once we're up to this point, we need to try to solve for y. So we want to think about if we have ln of y, what can we do? We can exponentiate both sides. This is where it can get a little tricky, especially on this right side. When we exponentiate both sides, both of the sides of the equation now become exponents. So on the right side, I have e to the negative x to the negative 1 plus c. Now, one of the biggest mistakes is breaking up that e to a sum. E to a sum means that we're going to take e to the negative x to the negative 1 times e to the c. This is the biggest mistake on a test because what we're not doing is accounting for when you have a product with the same base, you add the exponent. So think about going backwards. All we're doing here is splitting it up, which we're not used to doing all that often. Now the right side has e to a power, and I know e to anything is always a positive output, so these absolute values can go away. E to the c1, a constant to a constant, a number to a number is just a number, so I'm just going to call that c. So I'm losing the absolute values because this right side is always going to be positive. I'm making e to the c just a constant c, so I get y equals c e to the negative 1 over x. Now I'm going to use the point that was given, this 1, 3, plug in 3 for y, 1 for x, and I'll get c equal 3e. So once I do that, I can go back to my equation, my general equation, and find the specific solution by plugging in 3e for c. When I do that, now I have these two bases that are the same, right? So I'm going to add their exponents. So I get y equal 3e to the 1 minus 1 over x, or we could write it this way. So that's an application of a differential equation. Instead of just saying solve this differential equation, they're writing it as a slope. Now they will, in some free response questions, ask you to do that, and in another part ask you about an equation of a tangent line. So you want to make sure you know the difference. Okay, the next one you already did on page 19. It was number 3. It's a really good one. Like if you go back to page 19 and you struggled with that, you might want to do that one again, and you have the solution for that. So it's a good practice problem. Okay, the next thing I want to do is go over some homework questions from that bookwork on section 6.3. So, and like I said, I did this in the video that's for whatever reason coming up as private and I can't change it like I normally can. But what I wanted to do was go over these 3, 13, 19, and 39A. Those would have been the presentation problems. So number 13, just going through the steps, hopefully you knew to separate the terms, put one term on one side, one on the other, get all of your y's with your dy, x's with your dx. So then you can integrate. I integrated the left side. Now I'm going to integrate the right side using a little u substitution. And once I get to this step, to get y equals, I need to exponentiate. And again, that means that ln absolute value of y and ln of x squared over 2 plus c are the exponents. Now this, just like in that last problem, this is e to the ln of x squared over 2 times e to the c. E to the c, a number to a number is just a constant, so we'll let that be c, and then we get e ln of x quantity squared over 2. Okay, was it 19 and then 39a? So 19 is the next one. So looking at this one again, there are actually two terms. It looks like a lot, but there are two terms. Put one on one side, one on the other. Make that dy dx, change the y prime to dy dx. And then separate the variables. So we're going to be dividing both sides by 1 plus y squared. We're going to be dividing both sides by 1 plus x squared. We have to use u substitution in both cases. And then this step we're going to get a little bit, we're going to have to use those properties of logs, because when we use the property e to the ln, the e and the ln have to be right next to each other. If there's something in front, then that's not going to work. So we're going to make this 1/2 in both cases the power using that property of logarithms. Then we can exponentiate. The e and the ln are right next to each other, so we can get the square root of 1 plus y squared. On the right side, remember that that whole thing is now the exponent, and we can break it up into e to the ln of 1 plus x squared to the 1/2 times e to the c. That times e to the c is going to become my c value. And then the e to the ln cancels out. We'll get 1 plus y squared equals c, 1 plus x squared, when we square both sides. Now notice if I square c, I'm just going to call it another c value. And then I'm going to put in the initial condition that they gave, the 0 root 3, find out c is 4, and do my best to solve for y. Now, oftentimes they will let you leave it as a y squared. If they specifically say find f of x or y, then we would have to solve for y. Okay, and the last one, all right, this is a good one. This is like that last example on page 28, so if you need more practice on it. dw dt, I only wanted you to do part A of this one, because what I want you to notice is we cannot distribute this k. If we distributed that k, we'd get 1200 k dt minus kw dt, and then it's going to be impossible for us to separate the w's and the t's. So you want to think about this whole thing being multiplied by dt. So divide by 1200 minus w, multiply both sides by dt. Any scalar, keep away from what you're solving for. So we're solving for w. So we'll put that k on the other side. When we do a little u substitution, we have to balance with a negative, and we're going to get to this point, negative ln absolute value of u equals kt plus c. I cannot exponentiate until the e and the ln are right next to each other, and I really don't want to use properties of logs on this one and make it an exponent, because then I'm going to deal with fractions. So instead, I'm just going to multiply the entire equation by a -1. Then I can exponentiate both sides. Remember, this means e to the negative kt times e to the c. E to the c is going to give me that c value. So I have y equals c e to the negative kt. And instead of the y, I have 1200 minus w. I can solve it for w. Use the initial condition of 0, 60. Find out that c value to get that equation.